Alright, in this video I'm going to cover setting up Betaflight, specifically the Betaflight F4 board, the new one. I'll show you this sweet frame because we're all FPV geeks. We've probably all seen it. This is that Astro X X5 True X Silky edition. It's just nice. So I'm going to be mounting all this stuff on this. In addition, I'm going to be running the Cobra motor 2207 2450 kVs. And thanks to Cyber Monday, the Rotor Riot store had them for like $16. So I've got a set of the VEC blue ones coming. So not one for matching stuff, but I thought, hey, why not? It was a good excuse. The blue ones might match this these blue standoffs. So that might be cool. So later segments of this video, you might see the blue motors. Anywho, so we'll get to it. I'm using, as I said, the Betaflight F4 board, and I'm also using the Betaflight branded 32-bit ESCs. FPV model makes the flight controller. I don't know if they do this or not. I think they. I'll have to check. Anyway, these are the Betaflight 32-bit ESCs. They do telemetry, got a LED on them, what have you. For my video transmitter, this time I'm going to be using the Raceday Quads Mach 2. I usually use the TBS Unifies. They're awesome, tiny, and they have the smart audio, and they have clean video, and they're powerful. I love Raceday Quads as a company. I think they're awesome. So I thought I'd try their video transmitter. It too does 800 milliwatts. It's got smart audio control or audio control. I don't think they're allowed to call it smart audio. I think that's TBS's term for it, but we'll call it audio control. It's got solder pads, which I like. I'm not making anymore. I hate doing wire-to-wire splices. It's a pain in the butt. So I'm psyched for some solder pads. It's got pit mode, all that stuff. So that's the video transmitter. Using TBS Crossfire. It's the hotness, apparently. So I like it, though. I use it on my KISS setups. It's awesome. I don't necessarily fly long range, but I can definitely feel the responsiveness of the CRSF protocol. So I converted all my stuff over once the hardware came down in price. It was no brainer. I bought the micro bundle for $99, and then an additional 3-pack of receivers for, I don't know, $100 or something. So it's worth it. So I'll be doing that, and that. Some other things I told you I'm going to do audio control, so I can change transmitter settings, transmit power. I'm psyched to use, I don't know what version of Betaflight 3.2 the feature came in, but you can now change your FPV camera video quality settings. You know, your brightness, your contrast, sharpness, all that stuff. You don't have to use that stupid joystick anymore. You can do it right from, you can do stick commands on your transmitter when you're disarmed. I forget which direction you move the yaw stick, but it's the opposite direction than the Betaflight OSD. Anyway, once you do all the steps that I'll describe, you can then change your camera settings right from inside your goggles. Awesome. So this is the bottom of the board. I'm just going to quickly go over these connections. I've tried to do this video like 10 times. And each way, once I think I've got it wired up the way it needs to be done, there's some nuance or something I didn't account for, so I have to change it. So what you're going to get is a condensed version of all the little things that I learned along the way. Hopefully I'll be able to put it all into one video. So all right, so the connections, like any other flight controller, these are your motor pads, motor wires, positive, negative, simple stuff. Battery, all, breeze easy. The connections on this side of the board here are for, there's some UARTs, LED, camera, video in, video out. So let me start in the top left corner here. You'll notice there's 2 ground wires going into this this pin right here. Actually, let me zoom in. That's a little better. This pin right here is for the ground. The documentation suggests that you put both the video transmitter and the camera's ground into that pin hole, pin, whatever, pad. So that's what these connections are here. I'm not powering my camera from the provided camera pin. I was reading on RC Group, some people were having noise problems. So both my transmitter and my camera can handle higher voltages. So I'm just going to pick up the battery voltage from these motor pads. So this one here goes to power to the voltage in on my transmitter, video transmitter, and the camera power is here. If you weren't going to do that and you were going to do it by the provided pins, you would obviously use that pin right there. That would go to your voltage on your camera. And depending on the camera you're using, if it's a 5-volt variety, these jumpers right here, for 5-volt, you bridge the center pad and this 5-volt pad, put a solder blob right there, and that'll make 5-volt come out of that pin. If your camera requires higher voltage, then you would bridge this center pad and the pad to the right, put a little blob right there of solder, and you'll get line voltage, so VBAT. So whatever, if you're using 14.8 or whatever, 4S, you'll get 14.8 out of that pin. Again, I'm not doing that just because I'm trying to limit noise. So I'm hoping my video transmitter is meant to have very good noise filtering, so I'm hoping that handles it. If for whatever reason it doesn't, I may remove this power from this motor lead right here, and I'll take the power that comes out of the video transmitter right here. So that'll be my contingency plan. I also plan on running one of the 1,000 microfarad 35-volt 1,000 microfarad low ESR caps. I'll wire that in back here, and that should help with spikes and noise, and hopefully, so fingers crossed on all that. So that's the bottom of the board. A little more detail on this white wire here. This is the signal, or this is the OSD signal wire, camera OSD, for changing the camera settings. I've got that wired up to the LED pin on this F4 board. It's my understanding that most flight controllers that have dedicated LED pins, you can utilize that pin for the camera control signal wire. And you have to have, right here you see I've got a resistor in line right here. The Betaflight wiki will tell you all about it. Basically you need between a 150 and 600 ohm resistor wired in line. I tried it without just to see if it would work, and it didn't. So you do need the resistor from, at least for this board and this camera. So once I wired that in and tested, it works fine. So I've got that wired up to this LED strip pin. This is the signal wire right there. And there's some other things you have to do in the software itself, which I'll cover once I move over to the video capture program. So that's it for the bottom of the board. Flip this over. Get it lined up a little bit. Alright, so this is the top of the board. I'll go over the connections here quickly. This blue wire, this is for the audio control for your video transmitter. This will allow me to change my video transmitter settings from the OSD and also the Lewis scripts. I tried to get that working on a whole bunch of different ways. I tried to get it working on UART2 because I had that available to me. That did not work. Pretty simple stuff. You know, wire it in, you configurator, you pick the UART that you want to use, and you set it up for feature VTX, and would not work. So I punted on that. I also tried it on UART1. Didn't work for me. I think there's a conflict when I'll explain in a second. Well, I'll explain now. I originally had this over here is where I have my TBS Crossfire harness. I originally had that on, this is UART1 on the bottom here. I originally had it wired up here, realized that I made a mistake because the telemetry wires for the ESCs use UART1. So you need all 4 of these wires for Crossfire, and there would have been a conflict. So anyway, I had to desolder that and move it over to UART3. So I've got that set up here. But back to not being able to get audio control. I don't know why, but when I wired it in here and tried to set it in configurator, I don't know if there was a conflict or whatever, but it just would not save the setting. So punted on that and finally ended up trying UART6, and audio control worked fine. And I'm not the only one. I did some research on it, and Oscar Lang, I'm not sure how you pronounce his name, he confirmed that he couldn't get it working on either of these UARTs either. So save yourself some trouble and just use UART6 for audio control, for smart audio. And I believe I saw somebody else did the Immersion RC, the Tramp audio control on UART6 too. So I think it's safe to do VTX control on UART6 across the board. So that's that. These ESC wires right here, simple stuff. Ground, the middle wire is my telemetry, and this is just regular ESC signal, PWM, I guess. The telemetry wires will, on these ESCs, they'll be wired to right here. This will give me ESC telemetry, and then again, the white wire, I've chosen white. My white wire will go to that pad right there, and then this pad here will go to the ground. And then again, the reds that I've chosen here, they go to here. And then obviously on the other side of the board, the red and the black, those will go to the positive and negative. And that'll be for the ESCs. Obviously the motors go on this side. So that's that. Last thing is the Crossfire harness. I told you I have mine on UART3. And where is my, oh, it's right in front of me. The order is really self-explanatory. I chose the header that had just the 4 wires, and I guess the other 2 were blank. So I used that one, snipped off the other end of this, giving me just these 4 wires, and they literally wire in in the exact same order. Move this up. In the exact same order as they are printed on the receiver. Ground wire goes to ground. 5 volts goes to this. Right here is 5 volt. It's printed right there. Channel 1 goes to RX, and channel 2 wire goes to TX, all right in a row. And I already tested it, it works fine. So that's the wiring order for the Crossfire. And that's it for what I've got attached to the flight controller right now. All right, so I was going to unbind my quadcopter and show you the Crossfire binding procedure, but I did this in another video for KISS. It's the exact same thing, so I'll put one of those little cards up in the corner and refer you to my other video, but there's no mystery in doing it. It's pretty simple. If you've got your receiver wired up properly and you press the bind button on the receiver for just a second, it starts blinking green. On your transmitter that's loaded with the Crossfire Lua scripts, you just execute the crossfire.lua, and there's a bind menu item. You go there and you press bind, and it's pretty simple. Again, I covered it in a previous video that I'll link to it, and there's, you know, tons of other videos on YouTube, so it'll be pretty easy to find. I just don't want to waste your time doing the exact same thing I already did in another video. It's very easy to find. So anywho, here's a configurator. I'm going to run through it quickly, not waste your time with a bunch of stuff that you probably already know. Let me just go in here. I'm going to erase how I have this set so we can go through it. All right, so here's our erased board. So I'll just go down the line. For ports, these are the defaults for Betaflight 322. So UART1, as I mentioned earlier in the video, UART1 is used for the telemetry on the ESCs, the Betaflight 32-bit ESCs. So going to choose ESC for my sensor on UART1. So that's all I need to do on that line. UART2, I have nothing assigned to it. I had problems, as I told you. I was trying to get my video transmitter smart audio to work on it, and it would not work. I'm not sure why. I don't know if it needs an inverted signal for smart audio or not, but regardless, it did not work on my UART2. So anyway, from the video, the way I had it set up, nothing's on UART2. So I'm just going to remove SmartPort because I'm not even using SmartPort. UART3 is where we have our serial receiver. Remember, I moved the TBS Crossfire, had to wire it in on UART3, so you just need to choose UART serial RX on UART3. So that's all for that line. And then, as I told you, UART6 is the one that I'm using for smart audio. So I do not have a serial receiver on it, but I do have my TBS Smart Audio. So this configuration works right here. So I'm going to save and reboot that. Wait for the board to reinitialize. Reconnect. All right, so that was the ports tab configuration. This quad is a quad X, so I'll leave that alone. Since I'm using the new 32-bit ESCs, they can do D-Shot 1200, so I'm going to try that. I don't do motor stop. I leave disarm motors. I leave this motor idle throttle value and its defaults. This is an F4 board, so I can do 8K, 8K. So I'll do that. I've already done this, and I've observed the CPU load, and it's low. But if I thought I was spiking a little bit too high, I might uncheck the accelerometer. I don't use it for anything because I don't do auto leveling. But yeah, I'll just leave it checked for now. You can personalize this, give it craft name. This will show up in your CLI diffs or dumps or whatever. Probably also shows up in your OSD if you want to use that. I don't. Alright, receiver. We are using a serial-based receiver, but we're not using S-Bus. We are using Crossfire. Not using 3D, not using GPS. I'm not using an analog RSSI input either. Alright, so down to features. Telemetry's on by default. I am not using an LED strip because I've stolen its pin for FPV camera control, so I will leave that unselected. I do use air mode. I am going to use the Betaflight OSD. Obviously this is so I can change my VTX, transmit power, channels, whatever, through Smart Audio, so I need that checked. I do have ESC sensor, so I'll use that, anti-gravity, and dynamic filtering. And I do not want this to beep at me when I'm using. I have a beeper wired in now, so when I mess around on the bench, I'd prefer it not to make noise and wake up my wife. Save and reboot. Reconnect. Alright, so power and battery. This option here, obviously we're using our ESC for these voltage source and current meter source, so I'll choose ESC sensor. You'll note that it displays your ESCs down here. I'm not powered, so I'm not getting any readings, or I'm not powered with the battery anyway. Voltage sensor gets annoying, so I might uncheck that. I don't really pay attention to my battery voltage. I just pay attention to milliamp hour consumption. I will take a warning at 1,000 milliamp hours consumed. I do have some HV packs, so I could bump that up to 4.5 so it doesn't beep at me. Where's it? 4.7? I forget what it is. Anyway, so that I could lower this a little bit. Like I said, I'll probably turn this off because it gets annoying in the goggles. So that's it for that tab. I'll just save that. Fail safe. I really don't do much in here. You can read up on what you like. I like mine to drop, and I typically test this on the bench. I'll spin the motors without the props, and just turn off my transmitter, make sure it is responsive. I also have my my disarm switch readily available. I do the one I forget what it is, which switch label it is, but it's I can use my index finger to reach up and flick it at a moment's notice. I know that's not the same as failsafe, because a failsafe is when the radio can't communicate with a flight controller, but anyway, seems to work well whenever I test it on the bench, so I don't really mess around in here too much. I guess if you were doing auto leveling, you could have it set your position, your switch and stick positions to what you want, and have it hold there. But I don't do that. So PID tuning, like I said, I just erased this, so I don't really have anything in here. Not to mention PIDs and rates are, each quad's different. Each person's preferences are different. For my rates, I usually use super rates up around 8.2, 8.3. I do about a 0.5 expo if I want it to be smoother, and on the yaw axis, RC expo, I do about a 0.1. I've messed all around. I typically fly KISS, so I just try and make it feel like I'm used to. I am using anti-gravity. On this quad, I tested it at 5, which may be a little high for some people, maybe low for some people, but felt good on this quad, so that's what I'll be setting this one at. Excuse me. And I leave the threshold at 350. I'm going to mess around with dynamic filtering once I do my tune a little bit better. I'll probably bump up pitch and roll P, make it a little bit tighter, a little bit faster. Maybe give it a little more I. Again, these are all the defaults, so I haven't even tuned this. I have tuned it, but you're not seeing what I tuned because I erased it. If you're going to mess around with dynamic filtering, you go into this section here. You got to test your quad in between each step. Basically, you change the low pass filter to PT1, save, go fly, be a little bit aggressive, and then come back, land, feel your motors. Obviously, as in most things we do, we don't want the motor to be hot to the touch. You want to be able to hold on to them without it feeling uncomfortable. That's too hot. So it goes like this: change to PT1, go fly, come back, test, and then if all is good, you can disable gyro notch filter 1, save, go fly, fly into prop wash, do some flips, be a little aggressive. Don't just go hover. You want to, heat up the motors, come back, feel them. Again, if they're cool or just warm, you're fine. Go to the next step, disable gyro notch filter 2, save, go fly. Again, same thing, be aggressive, fly into prop wash, do some flips, rolls, some quick changes, work the motors a bit, come back, feel them. If they're still cool, you can go to the last step, which is, from what I've heard or read, is potentially the most dangerous one, and that is you turn off the D-term notch filter. If you have a noisy quad, or you just throw caution to the wind and turn these all off, turning this off has the potential to burn up your motors. But if you successfully get through all these stages, it's my understanding that you'll have very little, if any, prop wash at all. It's supposed to really make a difference. I don't know from experience, but that's how you do it. So again, I haven't done any of that yet, so that's why there's no settings changed here. Receiver tab, this just shows how your switches and sticks are set up. I'm not going to go into this. Most people, if you're watching this video, you've done this before. I typically have my modes. I use an arming switch. I've got one set up for beeper, and I have another one set up for turtle mode. Pretty simple. I'm not going to go into showing you how to do that because you probably know how to do it, and if not, there's a million videos. Joshua Bardwell, as we know, he has a video for everything. Show you how to set up your aux switches. Don't do any in-flight adjustments anymore because I can do them right on the ground from the goggles, and it's easy. OSD, by default, everything's selected. I usually only show a few things. I typically don't let... Been doing this so long, there's been so many different iterations of, using external OSDs, integrated OSDs, OSDs on power distribution boards. But it's just a habit of mine. I choose whatever region I'm in instead of letting it do auto for whatever reason. Sometimes I think fonts can get screwed up, and the fix is typically just pick your region, so I do that. And I typically do a timer. I do my VTX channel sometimes I don't. I do milliamp hour drawn. I will do, I think I do voltage just because, even though it's not necessary. And then I'll typically do some RSSI, depending on, I show it, but the value behind it can be different depending on how I set it up in the Crossfire. If you go to channel map in Crossfire on the receiver tab, channel map, you set channel 12 to be receiver link quality, and then you can set that on in the receiver over here. You put that, I set it on channel 12, and this value right here will match my signal strength, and then I can use that in my OSD, or I can show it on my Taranis, either in a line, I can do a bar or numbers or whatever. So you can do that. OSD is where we left off. So again, whatever you want, this is where you do it. I think I do my timer 2 as my source, and I do total armed. You'll set a timer for, I don't know, 3 minutes. Depends on how hard you fly and how large your batteries are. The last bit, which gets a little complicated, is the whole finishing up the FPV camera control. You do that stuff in the command line. I got a lot of the information from the Betaflight wiki. You just go to the Betaflight where you get the builds. Go to the wiki on the side down here. We've got, where is it? Oops, went too far. Camera control. Whoops, well, it would help if I went to the wiki. Scroll down to camera control. All right, so what we need to do is we need to paste in a couple of commands. First and foremost is we have to assign the pin. Remember, I wired up to the the LED strip pin. So in resources, I got to determine what pin is being used by the LED strip first. So we do that by doing the resources command. RESOURCE. And I've done this before, obviously, so I know it's B06. LED strip is assigned to B06. When I was doing this originally, I had noticed this LED, and I wasn't sure, is it LED strip or is it LED? On the Betaflight F4 board, it is B06. So now that we've identified that, you just supplement or substitute B06 for pin. So the command you need to use is resource camera underscore control B06. And what you find out, resource camera underscore control B06. When I do this, I'll find that, oh, B06 is already assigned to these other resources. And so what you have to do is you have to free up these resources by doing the command resource. And then we'll start with motor 5. So I'm going to do resource motor, motor 5, none. And you'll see that it freed up. And now I think if I do the same command, oh, never mind. And then I also need to free up LED strips. So I'll do resource LED underscore strip. And I believe if I look up here, it's not just LED strip, it's LED strip 1. So let me look what is named. That resource is currently named. Yeah, so I have to use resource LED strip 1. None. And now you can see it's freed up. So now if I try and reassign resource camera control B06, it should take it. And it does. And then one last command you can do is this here, this set camera control key delay to 125. I've done this with and without changing this value. It was a little flaky, so I'm bumping it down to 125, but the range is between 125 and 180. And what this means is when you do your stick commands to navigate through the FPV camera's on-screen display, it's how responsive the stick is, and when you're doing your selections, it's setting the delay. So if you move your stick and it's, you know, it skips a couple rows rather than just goes down one, then you'll want to lower that value. Conversely, if it's just too slow, you might want to bump it up so it's more responsive. So I will do this. All right, so that's it. All right, I'm just going to run through BLHeli Suite real quick. It's virtually the same as it was with the BLHeli ESC and whatever was before that. Just go to BLHeli, search for it, go to this WordPress page. It'll have a link to the different suites. This is the BLHeli ESC. This is BLHeli32. Download that, unzip it, and in your folder, once it's extracted, you can launch it. First thing you want to do, if you wired up your flight controller the same way I did with the telemetry wires, remember I did the ground wires also. I don't know if that has any bearing on the success people have with connecting. I've never had a problem if I do it this way. First thing you need to do is choose your interface. So we're doing Betaflight clean flight because we're letting the flight controller be the interface between the ESCs and the this suite, the configurator here. So choose that, boom, done. And then COM port 9, that's the same COM port that I was using in BLHeli, in Betaflight, and you can see it's right here. So that's it. If I try and connect right now without having a battery supplying power to the ESCs, I'll be able to connect to the flight controller. Usually gives you feedback. All right, but if I were to do check ESCs right now, it would fail because the ESCs aren't powered up. And you get this. So what I'm going to do is plug in my battery. So I still obviously plug the flight controller still plugged in to the laptop. Anytime I plug in my quad on the bench, I use my smoke stopper. It's just force of habit. Also, I have my props off, but if you didn't and you had a smoke stopper, it'll actually limit how fast your motors will spin up. So can't impress upon people enough. Smoke stoppers are awesome. So anyway, powering up the quadcopter now. So now, if I did check, I don't know if I have to disconnect and reconnect. This may just connect, and it did. So getting feedback from the ESCs. These are your 4 ESCs. You can configure them individually. This is just looking at ESC number 1. Anyway, I've flashed them Out of the box, I think the revision was 3.2.1, maybe. So I upgraded those. I think, forget how I did it. I think I just went to Flash ESCs, Flash BLHeli. It knows what ESCs I have and offered the most recent version. I just chose the latest rev. And you have to do this if you just say okay, do it 4 different times, it'll flash them all. So the default settings, I haven't changed much from the defaults, with the exception of I added some current protection. I did a quick little peek on FPV model site, and these Betaflight 32-bit ESCs can burst to 45, so got current protection, why not try it? If I find that it's somehow crippling my motors or limiting them, and I would rather burn up an ESC than have slightly less performance, well, maybe I would do that. But anyway, I'm using some current protection. And then the only other thing I changed, aside from the LED color, and the startup beep volume, was this PWM frequency. If you look in the info, the PDF, you can just, kind of inform yourself what all the different things are. It mentions that the PWM frequency, the higher, the smoother. So I said, yeah, I'll take smooth. So I just cranked it up to the highest setting, which was the 48 kilohertz, and worked fine. I've flown this quad set up this way. I don't know, I've probably done 5 packs, not a lot. It's been cruddy weather here, but I've had 0 desyncs, smooth as can be. So, take that for what it's worth. I haven't hesitated to fly over, parking lots and stuff, so I'm not worried that, maybe I should test it more for reliability, but it's been fine. So anyway, I changed that, and this startup beep is like, I don't know, 40 maybe, the default. Yeah, default is 40. So I don't need it making a bunch of noise, so I just turned it down to 10 just because. Don't need to calibrate your ESCs because does it for you. And that's it.